Good morning. I just want to make another video. I'm just fascinated with this. It blows my mind. This is my makeshift Newman motor. It has no iron in it, so there's no cogging. It turns. The only thing that makes it go is the big coils pulsing and pushing the magnets or pulling the magnets. Actually doing both, because one coil fires and there's two magnets. It'll pull one up and push one down. And then when it turns around 180 degrees, then the opposite coil will fire and push one up and pull one down in the same direction. So these coils alternate back and forth. So what I find really interesting is that this little motor here, I got it fixed up so I can hook it up to this, and it'll now this here's got some cogging to it. It's got some resistance to turn it. It's got like 6 cogging points where it hits the goes across some iron core or whatever it is. And okay, so now it's in place. I guess I should have showed you here. Let's show you here. Take it out. Okay, this is what it turns like without nothing in it. Okay, and the pop in you're hearing are these little reed switches. It's kind of weird. So, okay, so now I'm going to put this in it, and this one here has got some cogging to it, so there's some resistance. So you can see there's quite a bit more resistance. So this is the battery back, 12-volt battery pack. I got wires hooked up, so I'm not going to pull it all the way out. But so the ground wire off of the motor, we'll hook it up over here. This is the ground. Okay, so I also have the ground from the capacitor going to it. So I'm not using the capacitor with this motor yet. So we'll hook this up. See, the red wire goes down here because this is the red wire coming off the battery. So, okay. So it turns at a pretty good clip. But the fascinating thing is when I hook up the capacitor, watch what here, I'll turn this on. Turn the meter on. The meter's hooked up to the capacitor. We'll set it over here so we can see it. It's actually got voltage in it from last time I used it. Let me get this here around here. So I'll touch this on the hot wire. It'll use up that energy real quick. Now every time I take it off and touch it, no, it doesn't speed up or slow down. Usually it drops even farther. There it goes. So take it off, put it on again. It just drops down. Okay, but you can tell it doesn't make any difference in the speed of the motor. It's the same. So what I'm going to do, I'm going to shut that motor off. This is what's fascinating. Now I'm going to leave this motor hooked up, and it's got extra drag, so it actually has to do more work. Plus it's doing the fan. Okay, so you can see this here's got 1.130 volts. So this is already hooked up. All I got to do is flip the switch. So I'll flip the switch. Okay. I know what you're thinking. That motor turned it over faster. Well, you got to remember that motor there doesn't have any cogging, so this motor didn't have to turn over anything with resistance. But that motor's got to turn over this, and it's got some resistance. So now I'm going to touch this on the capacitor. I want to hook the capacitor up. Watch what happens. That's just fascinating. And this is a Newman motor. I don't have it shorten out at all, except for the 180 degrees every time it fires. I don't have any extra shorten out. And this is just with the capacitor. And I'll give you the values of the capacitor. I'll take a screenshot so you can, or I'll put it on there so you can take a screenshot. If you want to try to find the same kind of capacitor to duplicate this. I'll take off the capacitor. Slows back down. So let's compare. Okay, this is the motor, the Newman motor, turning over this motor and running the fan with the capacitor. That's the speed of it. So now I'm gonna, that's how fast, okay, so now I'm gonna shut this off. I'm gonna turn this off, and I'm gonna hook up this little motor again. Let's see. Okay. Wait a minute. What's going on here? That's the wrong one. Why was it working? That's weird. Okay. So now this motor's hooked up, and it's doing the load. And I think it's actually moving a little bit slower. So let me undo it again. Let's shut this one off, turn this on, then hook up the capacitor. Yeah, I think the capacitor's turning it over faster. And if I don't have this motor to turn it over, or don't have this motor to have to turn over, let's see if it goes, how fast it goes now. So turn it on. I'll take the red wire from the capacitor. Oh yeah, it's blowing some air now. But that just fascinates me. That this motor, you know, and the only thing I can see that's any different, I don't understand the specifics, but this has cogging, so it's got an iron core that the magnets are going by. That does not. That's the only difference. So I'm not sure what if you have any knowledge on this and can explain it to me, please leave a comment. I know John Bedini understood it, Joseph Newman understood it, and but I really don't get it. This is supposed to somehow short out the radiant energy from being able to help it run, where the way this is made, it doesn't. So it actually using the energy around us to help it run. And the capacitor is what's translating that energy into usable instantaneous current. I understand what's going on, but I don't understand how it's working. Why doesn't this do the same thing? So if you have any ideas, any comments, just an opinion, I'm open for anything. So you guys have an awesome day. God bless, and we will talk to you soon. Bye. I just happened to think, there's always someone that makes a comment that, why didn't you short out the capacitor before you started? You know, it's just, the capacitor is just a battery, and the capacitor is not a battery. They have super capacitors that can act like batteries, but this particular capacitor, if you don't have energy going in, there's nothing coming out. So I went ahead and shorted it out. So I'll show you. Short it out. Okay, it's dead. So we'll start the motor up, and then I will touch this on here. Now rather that energy is coming off the batteries, it can't be coming all the way all of it off the batteries, because that motor there, it only comes up to a volt 30, I think, if I remember right. But we'll short this out again. And we'll hook up this motor back in. Okay. Easier said than done. There it goes. Okay. So, got the black wire already hooked up. Now we'll hook up this one and get it started. Okay, so now it's cruising along. Okay, now this is a capacitor. So I'm going to plug it on, put it on. Okay. Yeah, it goes up to about 170 now, 180. So why doesn't it go up as far as it does with the Newman motor? I really don't know. So any ideas? Please leave a comment. God bless you guys. Have an awesome day. And I shorted out the capacitor. I'll do it again. So we'll short out the capacitor. So it's shorted out. Go ahead and take this off. We'll turn the Newman motor on. Let it get started. Then we'll hook up the capacitor. It's shorted out. Doosh. Now the thing is the capacitor is actually hard on these reed switches. I'll show you. I'll turn off the. Right now I don't have the capacitor hooked up. I got my wire right here. I'm gonna turn the light out. You should be able to see the reeds sparking a little bit. See them sparking a little bit. When I hook up the capacitor, I'm gonna touch it here and then watch it. Now you can see them really spark. It actually burns the reed switches out a little bit quicker. We'll take the capacitor off. Capacitor on. So I mean I could play with it like this for a little bit, but I'll end up replacing the reed switches. I started off with like 20 reed switches. I think I have 2 left. So until I can find some more reed switches, I'll probably be done playing with this after a little while. But the question still remains, why? Let me short this out real quick so there ain't no juice in it. Okay. And we'll shut this down. Why does the capacitor charge up with the Newman motor? Not so much with this. I mean, why does it make a difference? When I hook the capacitor up with the Newman motor running, you can see more power, speeds up. It can even carry this motor. But this motor, even though this doesn't have any cogging to it and is really very easy to turn, this motor doesn't change at all when I hook the capacitor up. Speed stays the same, power stays the same. The capacitor might come up just a little bit, and I think that's probably the battery. But I don't understand why this motor, what do they do with this motor that keeps that energy from charging the capacitor? I guess that's my question. Alright, well, God bless. Thanks for watching, and look forward to a comment or two. Hopefully help me understand what's going on. Alright, God bless. Bye-bye. Almost forgot. I said I would give you the numbers on this capacitor, so in case you wanted to, if you had the means of getting a capacitor like this and trying it out yourself, this is what's on the back. So you can take a screenshot. I believe this capacitor, you can tell it's pretty beat up. It came off of, I think there was 3 of them in parallel, and it was hooked up to a stereo to power the subwoofers in a car. Alright, well, that be that. You guys have an awesome day. God bless. Talk to you soon. Bye.